Welcome to the EPG Patashala, the lecture series in computer science, and the topic is compiler design. This is the 13th module and we are going to talk about the operator precedence parsing algorithm. Objectives of this particular module are to learn to construct the operator precedence parser and learn to parse the string by referring to the operator precedence parsing table. So, we have constructed the operator precedence parsing table in the previous session, okay, and based on that we are again going to construct what is called as a precedence function. That is, the operator precedence parsing table is typically represented using a precedence function. That also we are going to see in this particular module. The keywords operator precedence parsing and precedence functions. So, the parsing algorithm. So, last module we discussed about the operator precedence parsing table where it is going to be between the terminals, and the table entry will have the precedence relation, whether it is equal precedence indicated by an equal to operator or whether one will have a higher precedence over the other operator indicated by greater than or less than operator. So, the precedence table will basically consist of less than, greater than or equal to as a table entry, and this table is constructed between the terminals of particular grammar. Now, the prerequisite for this parser is, no two adjacent non-terminals should be there. So, you should basically have non-terminals occurring one after the other. So, that is the prerequisite. So, you cannot have a sequence of non-terminals together. That is the prerequisite for this particular parser. Then now, this is going to be a very small class of grammar. So, let us look at the parsing algorithm. So, the input string is terminated with the dollar, similar to the previous condition. In the earlier parsing algorithm of LL parser or the simple shift reduce parser, we had terminated the string W with a dollar at the end, indicating it is going to be end of input. Same thing is happening here also, and let a pointer P be pointing to the first symbol of the string W. Now, this is carried on till you would go to one of these states of either accepting or an error state. So, if dollar is on top of the stack and P points to dollar, then return. So, this is the terminating condition. So, where you have a dollar and a dollar, okay, dollar in the stack and the dollar in the input, then it is going to be successful parsing. Okay. Else, supposing say the topmost terminal on the stack, okay, and let P be the symbol pointed to by P. So, you have A on the stack and P is the input, and supposing B is the input which is pointed by the symbol P, and supposing if A is less than B or A equal to B. Now, this means that A has a precedence less than B or A has a precedence equal to B. A and B has got equal precedences, or if A has got a precedence less than B, then you do a shift action. So, shift in the sense that push the symbol B onto the stack. Already the symbol A is on the stack, now you are going to push B also onto the stack. Now, then you advance the input pointed to the next symbol. So, this is one operation. So, looking at the precedence of the operators A and B, where A is available in the stack and B is available in the input. Now, the parsing table is looked upon to check for the relationship between A and B in terms of the precedence relation. If A is less than B, you basically say that push B into the stack, or if A is equal to B, that is the input symbol which is on the string input and the terminal which is available on the stack, okay. Precedence relationship is basically compared, and if the symbol on the stack has got a lesser precedence or equal precedence than the input symbol, then you push the input symbol onto the stack. On the other hand, if A is greater than B, that is the precedence of the stack symbol is higher than the precedence at the input, then you start reducing. So, reducing in the sense that you pop the stack until the top of the stack terminal is related by less than to the terminal recently popped. So, this is your terminating condition. So, you compare again the top of the stack terminal, okay, is related by less than to the terminal recently popped. So, unless, okay, you keep on popping till you have a stack symbol A, that is till this condition A is if condition is basically met, okay. So, I will keep on popping symbol from the stack till my top of the symbol is going to be having a precedence relation less than the input symbol. I keep on popping the elements from the stack. Now, If it does not match these two, that is if the table entry is going to be empty, then you call that as an error routine. That is you will say that it is going to be a incorrect input. So, this is the parsing algorithm. Okay. Now, based on this parsing algorithm, let us try to do this with the help of the relation which you have already computed by terms of the expression grammar. Okay. The expression grammar we already know it is going to be an operator precedence parsing capable grammar. It can be parsed using an operator precedence parser. So, therefore, we are going to consider the expression grammar and then use that to parse this. So, based on that we have already got the precedence relation here. So, you have here ID plus star and dollar, and this is the precedence relation, that is ID and ID you cannot have a relationship here. That is, the point is if ID is already on the stack, the next symbol cannot be ID, that is the understanding of this particular combination. And similarly ID and plus, so ID has got greater precedence over plus, and then here ID and star, ID has got greater precedence over star. This is the interpretation. Now, with this interpretation, let us just look at this parsing action. Consider the input string as ID plus ID star ID followed by dollar. Now, we are going to compare the precedence of dollar and ID. What did we say? If the stack symbol has got a lesser precedence over the input symbol, you shift. Okay. Else lesser than something or equal to, then you shift, else you basically call the reduce function. So, again I am comparing dollar and ID. If you could see that dollar has got a lesser than precedence than ID. So, therefore, I shift ID onto the stack. Okay. That is what is indicated here as action. So, dollar has got a lesser precedence over ID. So, I shift. Then I am comparing ID and plus. Okay. ID has got a greater precedence over plus. Therefore, I have to reduce this by E produces ID. This is actually an ambiguous grammar only. So, E plus E, E star E, E produces ID. I can also use this with reference to the unambiguous grammar representation where I have to change my precedence table accordingly. So, I basically reduce. Reduce means what here? I have to pop till I enter into a situation where I have a greater than relationship is going to be holding good. Okay, till is holding good, I have to pop symbols from the stack. Once I have a less than precedence relation between the stack symbol and the input symbol, I have to stop popping. So, again dollar and plus, it is a shift action. So, I shift. Dollar and plus and ID, it is a shift action. So, I shift. And then ID and star, okay, ID has got greater than star, therefore, I reduce. So, till what point will I reduce? So, ID and star, ID is greater than star, I reduce basically. Plus and star, okay, plus and star has got a less than relationship. Okay. So, after I pop ID from the stack, the input will have basically plus. If I compare plus and star, it is going to be plus has got less than precedence compared to star, therefore, I again shift. So, star is shifted, star has lesser precedence over ID. So, I again shift ID, and then now ID and dollar, if you compare, ID has got greater precedence over dollar, and if you remember, star has got greater precedence over dollar. So, again I pop, okay, and then plus and dollar, plus has got greater precedence over dollar. So, again I pop, okay. So, if you look at it, plus and star, dollar, I have plus has greater precedence over dollar. So, I basically pop. Plus and dollar, so again plus is greater than dollar. So, again I pop. Dollar and dollar, that is your terminating condition, which is going to be accept action. So, this is the fundamental behind the parsing, operator precedence parsing algorithm, where your input will also be only the terminals, your stack will also have only terminals, and because your parsing table is designed such a way that it is a table between terminals and terminals of a particular grammar. And based upon this, if it is less than, if the stack symbol has got a lesser or equal precedence than the input, you shift the input into the stack, else you try to pop, and you have to keep on popping symbols from the stack till the stack input has got a lesser than or equal precedence compared to the input string. When both has got a dollar and a dollar, is an accept action. Any incorrect combination, if it is not available in the table, in the parsing table, that is considered as an error input. So, now what is the drawback of the operator precedence parser? The operator precedence parsing algorithm cannot handle the unary minus if the grammar has binary subtraction operator. Supposing if I have A minus B, okay, A minus B is also there, that is E minus E is also there, and if I have to have also E produces minus E, okay, that is not possible to handle in the case of operator precedence parser. So, that is a drawback. Now, how is it typically handled? This is typically handled with reference to in the lexical analysis phase itself. Okay, the lexical analyzer will basically consider two different tokens, one for unary minus and one for binary minus, and that will be distinguished at the lexical phase itself, and that is carried forwarded in the syntax phase for parsing basically. Okay. So, the lexical analyzer basically can be made to return two different tokens for the unary minus and binary minus. The lexical analyzer will need a look ahead to distinguish the binary minus from the unary minus. So, if I have to look at minus here, I should look at whether there is a operand following that. So, A minus B, if it is available, then I will basically take care of that. So, this is how basically it is handled. So, it is handled by the lexical analyzer, but by the lexer to issue two different tokens, whether it is unary minus or binary minus. So, that is another drawback. So, this is the overhead on the lexical phase of the compiler. Okay. So, then we make theta is less than unary minus. So, this is the precedence relationship which is being set, and we say unary minus is greater than theta if unary minus has higher precedence than theta, and unary minus is less than theta if unary minus has lower or equal precedence than theta. So, this is basically done for any operator. Okay. So, this is done as an exception because it is a unary minus, and your expression will typically have a unary minus as one of your operators. So, the precedence table is typically stored as a precedence function. Now, we have just now seen that the precedence table will be between the terminals, and the table entry will correspond to the relationship which is less than, greater than or equal to. Now, in addition to this, there is also one more convention where the operator precedence parser typically stores the precedence relationship as a precedence function. Now, how do I construct this precedence function? The precedence function is encoded as a table with two functions f and g. Okay. Now, for symbols a and b, now the symbols are going to be your terminals. Okay. You will set f of a is less than g of b if a has got a lesser than relationship than b, and you will set as equal to if a has got equal to b, and you will set it as greater than if a has got greater than b. Okay. So, you look at the precedence table and you assign the function values as f of a is less than or equal to or greater than g of b, and this is done for all possible combinations of a and b. Now, where the table entry is empty, you will not have this relationship defined. Okay. Now, this is the algorithm. Create symbols fa and gb for each a that is a terminal or dollar. So, this is done for even dollar because dollar is going to be your end marker for the input, and partition the created symbols into as many groups as possible in such a way that if a is equal to b, then fa and gb are in the same group. Okay. And then you are going to group it basically. Okay. Create a directed graph whose nodes are the groups found in the previous step, and for any a and b, if a is less than b, place an edge from the group of gb to the group of fa. So, from gb to fa, you have a edge, a directed edge if a is less than b. Okay. So, a is less than b, so the direction should go from gb to fa. If a is greater than b, place an edge from the group of fa to gb, again the same thing. So, where you had from gb to fa, where gb has got greater than relationship than fa, so you place an edge. If a is greater than b, then you place an edge from the group of fa to gb. So, if the graph constructed has a cycle, then no precedence functions exist. If there are no cycle, let f of a be the length of the longest path beginning at the group of fa, and let g of a be the length of the longest path beginning at the group of ga. So, this is how you construct it. Let us take this example. Consider the expression grammar. So, it has got four operators. Expression grammar in the sense that it is a ambiguous grammar. E produces E plus E produces E star E produces ID. So, only these three productions are available in the grammar. So, you are going to create four functions f plus, f star, f id and f dollar. Now, this is your fa, a and b are terminals, right. So, you have here plus, star, id and dollar are the four symbols. So, based upon that you create functions for f. Similarly, you also create functions for g. So, g plus, g star, g id and g dollar are the four functions of g. Now, we know that g id, okay, when you remember the precedence table, the precedence table is constructed such that ID has got greater than relationship than plus star and dollar. So, I have an edge from ID to plus, ID to star and ID to dollar. Similarly, FID to G plus, G star and G dollar, whether it is F or G does not matter. The algorithm says that if FA is less than GB, okay, the algorithm says if for any group, any A and B, if A is less than B, place an edge from the group GB to the group of FA if A is greater than B. Okay, so whether I consider ID to be A or ID to be B, I will have to have edges from F and G respectively. Okay, and we already know that what is a table between all relationships basically. So, let us just look at the table for a moment before we actually get into it. So, ID is greater than plus, greater than star and greater than dollar. So, let us just look at this particular example alone. ID is greater than plus, ID is greater than star and ID is greater than dollar. Similarly, if you look at this, plus is less than ID, star is less than ID, dollar is less than ID. So, ID has got greater precedence than plus, star and dollar, that is your understanding here. So, if you basically look at this particular example, so constructing of the precedence function. So, directly let us just go to the construction. So, these 4 functions. So, ID has got greater than relationship than plus, star and dollar. So, ID is here. So, from ID I have an edge to plus, star and dollar. Similarly, FID is there. I have a edge from plus ID to plus, star and dollar. So, whichever operator has got higher precedence, from there you originate an edge and go to the other symbols. Similarly, I have to consider edges from star. Now, star and star, this star has got greater precedence, associativity, based on associativity, the first occurring star will have a greater precedence over the next occurring star. Similarly, star has higher precedence over plus, star has higher precedence over dollar. Then I have star and this plus and this dollar. So, okay. So, once I have this star, I cannot have this star again. So, star is again greater than plus and greater than dollar. Similarly, plus and dollar, plus F plus to G plus, F plus G dollar and G plus to F dollar. F dollar to G dollar, there is no relationship at all. This is your terminating condition. Similarly, here GID to FID, there is no terminating condition. It is going to be, there is no relationship at all. So, you basically have no edge between these. Now, after that you construct this table. This table is going to be the longest path for F plus, the longest path for F star, FID and F dollar. Similarly, G plus is the longest path originating from G, G star is the longest path originating from G, GID is the longest path originating from G. So, that will be 5. So, F dollar, there is no out degree for F dollar, there is no out degree for G dollar, therefore, it is 0. That is actually understood. On the other hand, G plus, it is easier to look at it. G plus, there is only one out degree is just 1 for this G plus node. So, that will go from G plus to F dollar, which is going to be of length 1, that is what I have indicated here. Similarly, if you look at F plus, okay, F plus basically has 2 out degree, one is here, other one is here. So, if you look at this, this is having the path length is 1. If you consider this particular path, okay, from F plus to G plus and then to F dollar, the path length is 2, that is what I have here. So, this will have the longest path available. Similarly, if you consider one more example, F star has got out degree as 3. So, I have to consider 3 paths. So, 1, 2 and 3, this is one path, okay, alternately 1, 2, 3 and 4 alternate path, 1, 2, okay. So, far we have got a path length of 3 or an alternate here directly 1. So, that is why I had taken the longest path, it is going to be 4. If you consider FID, okay, FID there is only one path here which is of length 3, alternate path of length 2, alternate path of length 1, but if you just combine FID to G star to F plus to G plus and then to F dollar, that is going to be of path length 4. Now, this is basically stored and that is used as a reference later. Okay. So, rather than the precedence table, this is what is shown, that is what I have shown here as FID to F plus and then this is the path length of 4 for FID. Okay. So, the length of the longest path is calculated from every node to other node, and so that is stored as a precedence table which is used by the operator precedence parser. The primary drawback of this parser is it cannot handle the unary minus operator. Okay. Then it can handle only a small class of grammar, and it is difficult to decide the language of the grammar for this particular class of grammar. So, error situations in this grammar, supposing there is no relationship between the terminal on the top of the stack and the next input symbol, that is a typical error problem. So, how do I handle it? It is going to be only a error recovery routine. A handle is found, but there is no production with this handle as the RHS, that is your situation. So, recovery is as in the LL1 parser, each empty entry is filled with a pointer to an error routine and matches what the popped handle resembles which right hand side of the production and tries to recover from that situation. Okay. So, to recover we must modify the stack, the input or the both. So, all the three possibilities can basically be tried. Now, these are empty entries. If I consider grammar having operator ID open parenthesis close parenthesis, that is E produces open parenthesis E close parenthesis and E produces ID. So, ID and ID we already know that there is no relationship existing. I am calling that as error routine 3, again similarly ID and open parenthesis. Okay, and close parenthesis and ID E3, this is E1 and the last two are E2 and E4 respectively. So, okay, what does this E3 basically indicate? It means that if I encounter first operand, the next character cannot be an operand, that is the understanding. Similarly, if I get an operand here, the next character cannot be a parenthesis, it has to be followed by a operator, then only I have to have the parenthesis. Similarly, here a close parenthesis cannot be followed by an ID, it has to be followed by a operator and then an ID. Similarly, if I look at the close parenthesis, it cannot be followed by open parenthesis. Similarly, I cannot have an expression that starts with the close parenthesis only, I mean without the close parenthesis, I cannot have the open parenthesis only. Similarly, dollar and dollar, sometimes it could be the direct symbol itself, okay, unless it is end of input, I cannot call it as a successful parsing. So, the first scenario is entire expression is missing. So, how do I recover? Insert ID to the input and you issue a message missing operand or no input. That is the first scenario, that is dollar and dollar situation. The next scenario is expression begins with the right parenthesis. So, therefore, you delete the close parenthesis from the input and you issue message unbalanced right parenthesis. Okay. And E3 is scenario ID or close parenthesis is followed by ID or open parenthesis. So, you can insert any operator plus or star here and then issue a message called as missing operator. So, these are the last one is open parenthesis alone, there is no close parenthesis. So, you have to issue a message missing right parenthesis here. So, these are the 4 possible error recovery messages. So, I have one more example here, ICT, SES, if condition then statement, else statement or A, and this is your condition produces B. This grammar can be parsed using operator precedence parser. I am computing leading of S and trailing of S. Leading of S is I, comma A, trailing of S is going to be E, comma A, and leading of C is B, trailing of C is also B. Based on this, you can construct the parsing table. The parsing table, you have to use the leading and trailing relationship and run the algorithm. If there is a non-terminal occurring in the middle, then both will have the equal precedence, and you have a set of rules. We have done this in the previous module itself. So, you can run this parsing table. Before that, let us just get this string. You have, this is one possible string of this grammar. Okay. So, basically you have the parsing table here which has been constructed for all the terminals, possible combination of terminals. Whatever is occurring, that is going to be an incorrect combination. That is, if you remember here I, comma I, what does it mean? If and a if cannot occur one after the other. If I have an if, it should be followed by a then. Okay, that is the understanding here. If I have a then, okay, I can have one more if available after the statement, that is your understanding. Okay. So, I call that as a less than relationship here. So, supposing if I have the same string here, I compare dollar and I would shift I less than B, again I shift, B is greater than T, so I reduce. Okay. Reduce means I have to pop the symbol, then I and T, again it's equal, so I shift. A, again I shift, A is greater than E, therefore I reduce this and pop the symbol T, A, and then I T, again T equal to E, so I shift basically, and then I basically go in a sequential manner, and all the symbols I, T, E are here greater than dollar, so I basically reduce and pop all symbols. Dollar is going to be an accept situation. Okay. So, this is one more example which we have seen. So, this module has discussed basically the parsing action of an operator precedence parser. We had the expression grammar as an example, and we had the conditional grammar if then grammar as one more example, and saw the parsing action of these two grammar by the operator precedence parser. And we also learned how to construct the precedence function for this particular operator precedence table. Based on the operator precedence table, you have to construct the precedence function and then store it as a table of longest path computation, which is used by the parser for parsing. Okay. So, and we also learned how do I recover from the possible errors that could occur in a operator precedence parser. So, we can basically issue messages, and then it is going to be a panic mode of recovery where I will still keep on deleting symbols either from the stack or from the input or both. Okay. Thank you.